Hey everyone, welcome back to StackTrekker. In the last video, we collected logs with FileBeat. If you missed that tutorial, you can find the link in the top right corner. Now it's time to dive deeper into visualizations and dashboards to better analyze and understand our data. Let's get started. Earlier, we created simple visualizations and a dashboard, and you're already familiar with mapping. Today, we'll briefly revisit these concepts without going into deep explanations. If you need a refresher, check out the previous tutorials. The links are in the description. In this video, we'll go through the full process, creating a mapping, uploading data, and visualizing it in a dashboard. So, let's create a new version of our movie titles. I've provided an updated mapping file, and you can see the URL on the screen. This URL will also be available in the description. First, we need to apply the new mapping. Open the mapping file, copy its content, and execute the command to update the index. Be careful with the URL as the index name has been changed in this version. Make sure you're using the correct endpoint to avoid errors. Now, we need to upload the updated data. The new data file is available at the URL shown on the screen, and you can also find it in the description. Download the file, then execute the upload command to insert the new dataset into Elasticsearch. Once the data is successfully uploaded, we can move on to visualizing it in Kibana. As you know, the first step is to create a data view. This acts as a connection between Elasticsearch and Kibana, allowing us to explore and visualize our data. So let's set it up. Navigate to the Data Views section in Kibana and create a new one. In the Index Pattern field, enter the name of our updated index for the second version of the movie titles dataset. This ensures Kibana recognizes and retrieves data from the correct source. Since our dataset contains historical records rather than real-time logs, we need to adjust the time filter to display the entire time range. By default, Kibana may only show recent data, so expanding the time range ensures that all movie titles appear correctly in the data view. Once the data view is created, we can verify that everything is set up properly by checking if the expected fields such as title, genre, release date, and rating are available. If something looks off, double-check the index pattern and ensure the data was uploaded correctly. Now that the data view is ready, we can move forward with exploring and visualizing our updated movie dataset. Let's create our first visual component. Navigate to the visual library and start a new visualization. For this, we will use Lens, which is the recommended way to quickly and easily create visualizations. Our goal is to create a chart that shows how many movies were produced each year. To do this, add the year field to the horizontal axis and set its function to date histogram. As the interval, select year so the data is grouped accordingly. For the vertical axis, we want to display the number of movie titles. Choose an appropriate metric, such as count, to represent the total number of movies per year. Next, rename the chart title to clearly describe what it represents. Once the visualization is complete, we need to save it. Provide a meaningful name for the visualization, but don't add it to a dashboard just yet. We'll organize all visualizations into a dashboard later. With that, our first visualization is ready. Now, let's move on to creating another one. The next visualization will show how many movies exist per genre. To achieve this, we will use a pie chart, which is ideal for displaying categorical distributions. Start by selecting the pie chart option. For the segment field, choose the genre field as a keyword. Since we want to display only the most common genres, we will select the top 10 values. This ensures that the chart remains clear and easy to interpret, focusing on the most relevant data. For the metric function, we will use a count, which calculates the total number of movies for each genre. This will allow us to see the distribution of movies across different categories in a visually intuitive way. Once the chart is configured, don't forget to save it. Give it a meaningful name, but do not assign it to any dashboard just yet. We will organize all our visualizations into a structured dashboard later. With just a few clicks, we have created a highly informative chart that provides an immediate overview of how movies are distributed by genre. This demonstrates the power and efficiency of using Lens for quick and effective data visualization. Now that this visualization is ready, let's move on to the next one. Here we want to display the top 10 highest rated movies in our dataset. For this, we will use a table visualization, which allows us to present detailed information in a structured way. I've already mentioned how powerful Lens is for creating visual components, and this also applies to tables. Lens supports drag and drop functionality, making it easy to build the visualization step by step. Start by dragging the title keyword field into the rows section. By default, it automatically creates a top 5 values range, but we need to adjust this setting. Change the limit from 5 to 10 so that we see the top 10 movies instead. Also, update the column title to make it more descriptive, and disable the other row as we only want to see the exact top 10 entries. Next, let's add more relevant columns. The second column will be year. Adjust the title for clarity. Since year is a numerical value, modify the visual representation to ensure it displays properly. Now let's add the IMDb rating column. Since the rating is not an integer, but a floating point number, adjust its visual representation accordingly to ensure accuracy. Before we finalize the table, we need to change the sorting order. The table should be sorted by rating in descending order, so the highest rated movies appear at the top. There may be a warning about approximation results, which means enabling precise results will slightly slow down the search, but provide more accurate rankings. Enable this option to ensure we get the correct top 10 movies. As always, save the visualization with an appropriate name, but don't add it to a dashboard just yet. We'll do that later. Now that we have our top 10 movies table, we can move on to the next step. So now we are going to create a dashboard. Navigate to the dashboard section in the menu and click the Create button to start a new one. At first, the dashboard will be empty, so we need to add our 3 visual components. Click Add from Library and select the visualizations we created earlier, the yearly movie production chart, the genre distribution pie chart, and the top 10 highest rated movies table. Once all the components are added, arrange them for better readability. Adjust their positions and resize them to ensure they fit well within the dashboard layout. The pie chart and yearly production chart might work well in smaller sections, while the top 10 movies table could take up more space for better visibility. Make sure the layout is clear and easy to interpret. If necessary, tweak the arrangement to improve the user experience. Let's add some interactivity to make the dashboard more dynamic. Start by adding a slider control to filter the data by year. This control will allow users to adjust the year range, and it will automatically update all visual components on the dashboard. There's no need to manually connect the slider to each chart. Kibana handles this automatically. Once the slider is added, save the dashboard to ensure all changes are applied. Now let's test how it works. Adjust the slider to change the time range, and you will see that all charts update accordingly. The yearly movie production chart will reflect only the selected years. The genre distribution may shift as certain movies are filtered out, and the top 10 movies table will adjust based on the chosen time frame. This interactive feature makes it easy to explore trends over different periods, giving a more flexible way to analyze the data. But this is not everything we can provide here in terms of basic interactivity. Now, let's take it a step further and create a drill down to enhance navigation and exploration. A drill down allows you to open another view from the current one while carrying over key parameters such as the time range, filters, and selections. This means you can continue analyzing data from a different perspective while maintaining context. For example, if you have a dashboard displaying logs and metrics for multiple data centers, you could create a drill down that takes you from the overview dashboard to a detailed view of a specific data center or server. In our case, we want to create a drill down that opens an extra view for the selected year. This way, instead of just seeing how many movies were produced in a given year, we will also be able to explore a detailed breakdown of those movies. This extra view will allow us to see the full description of each movie from the selected year, use search, filtering, and sorting to refine the displayed data, and maintain full dashboard interactivity while drilling into specific details. So here we can decide what action the drill down should trigger, whether to open another dashboard, navigate to a URL, or open the Discover page. In this case, we want to open the Discover page where we can explore the detailed movie data filtered by the selected year. To set this up, we provide a unique name for the drill down and save it. Additionally, we will create another drill down for the pie chart. This will allow us to filter movies based on genre, making it possible to explore all movies within a specific category in more detail. Okay, everything is configured, so it's time to test our setup. First, switch to View mode. This mode hides all configuration options, allowing us to see the dashboard as the end user would. Start by testing the year range slider. Adjust the range and check if all visual components update accordingly. Next, test the drill down for the yearly production chart. Select any year, right-click, and a menu will appear with available actions. Choose Open in Discover, and a new browser tab should open, showing detailed data for that specific year. Now, let's test the drill down for the pie chart. Click on any movie genre, again right-click, and another browser tab should open, displaying detailed information for movies in that genre. Finally, notice the play button in the year range slider. This feature allows us to animate the time range automatically. Click the play button and watch as the year range changes dynamically until it reaches the end. Everything is now fully functional, providing a seamless way to explore and analyze movie data interactively. So I hope this was interesting. Thank you for watching my tutorials. If you enjoyed this, please like the video and subscribe. See you later. Bye.